Today we're doing section 2.3 day 2 and we're talking about polynomial functions and how to graph them by hand. So yesterday's video, at the end of the video, I started using this vocab word of multiplicities, and what that means is the number of times a solution happens. So, for example, if you get an answer one time, it has a multiplicity of 1. If you get an answer twice, it has a multiplicity of 2, and so forth. The number of possible turnarounds you could have in a graph is always the highest exponent minus 1. Okay? And that is just the possible turnarounds. It doesn't mean that's how many turnarounds there will be. So if something is raised to the 4th power, you would do 4 minus 1. That means you would have 3 possible turnarounds. So going back to the multiplicity, if you have an answer of an even multiplicity, that means your graph will turn around at the x-axis. Whereas an odd multiplicity means it will cross through the x-axis. So real quick, let me just give you a visual. An even multiplicity would be like that, where it's turning around at the x-axis. Odd multiplicity would be it's crossing through the x-axis. Okay? So the steps to graphing. You're going to determine the end behavior, and that's a skill we practiced in yesterday's video. You're going to find the x-intercepts. You're going to find the multiplicity. And you're going to determine if it touches versus turns around. Some symmetry you can do tests for if you plug in the negative x and you get a regular x out. You can determine, not equal sign, you can determine it's even, and even means it's symmetric over the y-axis. And this is a typo, this should say f of negative x. If you plug in a negative x and you get the negative out front, that means it's odd, which means it has symmetry over the origin. And then again, our max turning points would be highest exponent minus 1. I'll write it out. All right, so let's go through one example, just doing some tests and creating the graph on our own. So based on this, so the first thing we're going to find, step 1 says determine your end, find your end behavior. So we look at our first coefficient. Leading coefficient and positive, highest exponent is even. Therefore, our end behavior is up, up. To find our x-intercepts, we are going to factor here. So I do a times c, which is 1. So multiplies to be 1, adds to be negative 2 would be a negative 1 and a negative 1. So this is a quadratic form, so all that means is when I split up the middle term, they're just going to both be to the 2nd power. And then we're going to group them. If you box, put these 4 terms in the box. So I'm left with x squared minus 1 over here. Oops. We'll take out a negative 1. I'm left with x squared minus 1. So I get x squared minus 1 and an x squared minus 1. And we know we set these both equal to 0. So when I do that, I'm going to get x squared equals 1 for both equations. And then we take the square root, and here I get x equals plus or minus 1, and over here I get x equals plus or minus 1. So in terms of our multiplicities, I got a 1 with a multiplicity of 2 because I got 2 positive 1s, and I got a negative 1 with a multiplicity of 2 because I got 2 negative 1s. So both of these represent turnarounds Okay, and I'm just running out of room there. Something else we can determine is our y-intercept. So we found our x-intercept, our y-intercept, and I probably should have put that on the steps of things we could find. You plug in 0, so when I plug in 0, I'm going to get 1, so I got my y-intercept. The even and odd isn't terribly important, but we'll just quickly run through it. If I plug in a negative x, I'm going to have a negative x to the 4th power minus 2 times negative x to the 2nd power plus 1. So this will be a positive x to the 4th. This will be a negative 2x squared, because the x squared will turn positive but times the negative 2. And then a plus 1. So notice it didn't change at all. It's the same as what I started with. So this is even, which means it's symmetric over the y-axis. All right, so let's get all this information on the graph. All right, so my y-intercept is 1, so I already have that. I don't need this here. Negative 1 is an x-intercept, and positive 1 is an x-intercept. So because I know my end behavior is up, up, I know I'm going to be in this quadrant, and I'm going to end up in quadrant 1. Because it's even, I know it's going to look the same on both sides. Because of these multiplicities of 2, when I hit this value of negative 1, I'm going to turn around. Then I turn around here, and I'm going to turn around again at the other x-intercept. And one thing I didn't go over, my first term was x to the 4th power. So my highest exponent was 4. If I do 4 minus 1, I have 3 possible turnarounds. And notice when you look at the graph, we have the 3 turnarounds that we would need. So here's 1, there's 2, and there's 3. So that's all for today. We'll practice tomorrow.